Somebody was waving a hand over here. Using single equation OLS, estimate the unknown parameters of the 3 share equations for which you have data. Well, now you have share equations for all 4.
Wow.
Yes, because remember I just said that I sent you an email earlier today.
Junior data.
Yeah. Because there were some people worked up about.
If I try to do it, you have found the share equation.
Well, somebody came to my office the other day, weeping and wailing and gnashing their teeth. And my position was that they were making a mountain out of a molehill if they looked at the definitions of the variables they were given. They could figure out the missing pieces. And finally I said, well, I'll just look for, I'll go back to the original green data set and you do that one. So the original green data set is much smaller. It has only 25 observations. It's there. But now it's got year, output, the price of output, quantity of capital, price of capital, quantity of labor, price of labor, quantity of energy, price of energy, quantity of materials, the price of materials, the quantity of value added, the price of value added, and then these Z's are explained in the data legend document that I attached, and we're not going to use them anyway. How many? Yes. If you take the top panel and you save that as a comma-separated values file from, say, Notepad.
Yeah. So we'll.
Yeah, but Laura says she doesn't know how to do that. So what you want to do is take each of the panels, save them to comma-separated value files, and then read them import them into Excel. It's just button clicking. You can even read a PDF file into Excel. Excel understands the PDF format. There's 25 years of data, and the legend is also given out there. Shows what everything is. So the more interesting question is why even think about gross output and the quantity of value-added output? Why is that even of interest? Why did it even occur to anybody to put both in the data file? When we talk about a production function in economic theory, what's the appropriate quantity? Gross output or the quantity of value added? Well, maybe I should add that question to this problem set now. Why is there an important difference? And which one are we interested in?
Is the quantity value added something that
you know what we mean by value added in this context?
I think I do. Does it refer to what happens at the margins, like incrementally? No.
No. Who remembers how you calculate GNP on a value-added basis? GDP on a value-added basis. Anybody? About half of my audience, I believe, from the Econ PhD program. Okay. Suppose that the miller reports to us that she sold 100 tons of flour at $5 a ton. Was the value of her output, $500? And then, of course, we could deflate it by whatever GDP deflator. So is the value of her output $500 or something different?
Something different. She didn't put costs.
What?
It's something different because she didn't put costs.
Yeah, something different. Her output is actually the value that she added to the bag of wheat that the farmer brought her. So you have to subtract out the value of the wheat that she hired as a productive input. And then you can talk about her output. So that's a fine distinction. For this homework, we're going to use QY, gross output, because as it happens, it works better for our purposes than it does value added. So in your intermediate micro theory text, and by the way, this distinction between value added output and gross output is not a distinction that's made at the level of freshman economics. And even at the intermediate level, it goes right over everybody's head. But by the time you get to a graduate program, then you should recognize that there's a difference. Okay? And so the outputs in this figure, these are value-added outputs that we take out the value of the inputs in the output. Okay? So there's a new data set. It should be somewhat easier, should be somewhat easier to work with. It should be manipulating. It should be more transparent. And the other problem with the old data set was that, of course, you had 3 inputs and the 3 factor shares added to 1. So there was a problem with the missing. The problem was not the one that was originally brought to me. The problem is that the factor shares had been rescaled by the person who originally put the data together. They were interested in a different question than the questions were interested in. And because the 3 factor shares that I gave to you in the original data set add to 1, the Translog function that I originally gave you was not correct, because I had 4 inputs there, so you'd have to drop some of the own terms and the cross product and the squared terms. And then, of course, if you blundered ahead thinking that there were 4 inputs, the fact that the 3 shares that you had added to 1 would then cause you problems later on when you're looking for those symmetry and equality restrictions that I applied to, referred to in the problem set. But now I have something else I want to look at. Where do these translog production functions come from? So I want to spend a couple of minutes, maybe, again, if you see where they come from, you'll have a little bit more intuition about the exercise that we're working on. Although my real interest, I'm interested in how you deal with these. I'm interested in how you deal with these first 1, 2, 3, 4 parts. I'm interested in how you do those, but the last parts, E through L, are really important because that's where the statistics part comes in. But the reason for doing this problem set is similar to the reason that I, in other semesters, used that bread and meat example, because it illustrates beautifully the points that I was trying to make in the very first week of class, that data analysis without theory is the same as theory without data analysis. You've got to have both. And so just looking for statistical correlations out of context doesn't have much value to it. These translog cost functions come from. So I just concocted a simple example to illustrate the origin of what I gave you in the homework assignment. So I said, let's suppose that production is given by the production function there, and that's the well-known Cobb-Douglas production function, first invented by Drs. Cobb and Douglas many years ago. They were both in ag econ departments out in the Midwest, and they wanted to model farm production. And I think they were doing it for 20 years or 30, many years ago. And so we're maximizing output subject to a cost constraint. So the production function takes this form, B0 times K to B1, so on and so forth, and then the cost constraint is that cost is equal to the price of capital times capital, price of labor times labor, plus the price of fuel times fuel, plus the price of materials times materials. So we could set up the Lagrangian, where we have our maximan and the Lagrange multiplier times our constraint, and the constraint is set up so that it's concave. So we can get the first order conditions, and the order in which they're done is capital, labor, fuel, and materials, and then the derivative of the Lagrangian with respect to the constraint. And we can solve for, given the first order constraints, we can solve for demand for capital, labor, fuel, materials, and we can solve for the value taken by the Lagrange multiplier, eta.